Hey again, class. So this is 7.4b Parabolas and Writing Equations, but now they will be shifted at the HK for the vertex. So looking down here, we have standard equations of a parabola, and again, upward will be of the form where 1 over 4p is positive, and then we have it set where y equals a statement. But now, since it moves hk, k is with y and h is with x, and that is the same throughout every equation here. If it's downward, now it's minus and it's a y equals. If it's to the right, then it's an x equals and a positive leading coefficient again. And then if it opens left, then x equals a negative. So some similar stuff that we've seen with parabolas, up, down, left, right, and then with the k and h being associated with x and y. So in this first problem, it's asking us to graph this equation here. First, we're looking at which way it opens. So we have a y equals and it's positive. So that means it's going to open up. So we're going to say opens upwards. Then we're going to see what our vertex is. So remember that k is with y and h is with x. So then our vertex is going to be negative 2, 5. So then we can plot that at negative 2, 1, 2, 3, 4, 5. We don't need those extra marks. Now we're going to find the focus, and we do the focus and directrix again using P, because P is going to be equidistant from the vertice here. So a positive P and a negative P. The focus point, since it opens upwards, is going to be above the vertice. So this is your vertice. Oops. Negative 2, 1, 2, 3, 4, 5. Vertice. So we're going to set 1 over 8 equal to 1 over 4p. So 4p equals 8. So p equals 2 then. So from the vertice up 2 is the focus point. And then down 2, this is that directrix. This is the line here. And so the focus then is negative 2, 7, because it's plus 2 from this point, and you can see it on the graph, negative 2 up 7. And then this line here is the line y equals 3. So the directrix is y equals 3. Now, to find out kind of how wide our parabola is going to look, we see what the total distance from focus to directrix is. So that's 4 units. So we go 4 to the right, 1, 2, 3, 4. And then 4 to the left, 1, 2, 3, 4. And then we can see kind of some points that our parabola is going to go through to draw the parabola. And then reiterating the distance from this focus point to that point down to the directrix, this is the same distance here, those two lines. Now moving on to the second example, we have an x equals. So now we're seeing if this is positive or negative. So it's positive. So that means when it's x equals a positive, it opens to the right. H is with x and k is with y. So then our vertex is going to be 2, 6. So we can plot that on the graph. 1, 2, 1, 2, 3, 4, 5, 6. This is the vertex here. Then I'm going to want to find out what P is. So we have 4 over 1 equals 1 over 4p. And we can do cross multiplying here to solve, like so. So then we have 4 times 4p equals 1. So 16p equals 1. So P equals 16. Excuse me. P equals 1/16. So we found P equals 1/16. So it's going to be really close here for both the focus and the directrix from the vertice. We're moving over P, which is 1/16, to the right for the focus. So it's really close here. That's our focus. And then our directrix is going to be 1/16 back. So you can see it's really close. So then for the focus point, it would be 2 plus the 16th for P, 6. And then the directrix, since we were at the point 2, 6, we're really just looking at the x because we're moving to the left 1/16. So 2 minus 1/16, that'd be 1 and 15/16. And that's the line x equals 1 15/16. You can also make those irrational if you want. So for the focus point, you would get 33 over 16 sixths. And then you could also get the line x equals 31/16. Either will be accepted. Then we can draw our parabola, and since it's a total from focus to directrix, that's only going to be 2/16. It's going to be really small here for the parabola. So we're just going to approximate it and make it as accurate as we can get there. All right. This one's pretty short. Now we got some writing of the equation of a parabola. And in this case, they want us to write it with a vertex at 1, -2 and an x-intercept at 3. They also tell us it opens to the right. So since we know it opens to the right, it's going to be of the form x minus h equals 1, because it'll be positive if it opens to the right for this 1 over 4p, and then y minus k squared. The vertex, that is our hk. So if we graph this, we get 1, -2, that's our vertex. And then they also say it goes through the point, or the x-intercept, right here at 3. So it opens to the right like this. But we need to solve for p to write the standard form of the equation. So we didn't get p, but they did give us the hk, which was the vertex, and they gave us a point that the parabola goes through. That's the x-intercept. That point is 3, 0. And since we know that point, that's an ordered pair of x, y. So now we can plug in to solve for p because we have an x, an h, a y, and a k. Here's your hk and here's your xy. So I'm going to plug in my hk first. So I have x minus 1 equals 1 over 4p times y, it'd be minus a -2, so plus 2 squared. Now I'm going to plug in my xy, which was over here, the point that the parabola went through. So I have 3 minus 1 equals 1 over 4p, and then y was 0 plus 2 squared. So then we have 2 equals 1 over 4p times 2 squared. That doesn't look like a 2. So then we have 2 equals 1 over 4p. 2 squared would then become 4. To keep it in 1 over 4p form, I'm going to divide both sides by 4 here, since it's the product times 4. So then we have 2/4 equals 1 over 4p. We can reduce 2/4 to half. So now we have half equals 1 over 4p. So that means that 2 equals 4p, and then solving for p, we're dividing by 4, we get half equals p. Because when I took 2 divided by 4, it reduced to half. So now we have a p, and we have the standard form right up here for the equation of a parabola that opens to the right. So I'm going to plug in my p, and I already have my hk in that form there. So then over here we have x minus 1 equals 1 over 4. P was half, and then y plus 2 squared. So simplifying, we have x minus 1 equals 1 over, so it'd be 4 divided by 2. So 1 over 2, y plus 2. So this would be the standard form here. And then next we have a word problem. So this will be an application of a parabola. So there are some real life uses that you might not see during class, but this will help illustrate that. So it says an engineer is designing a flashlight using a parabolic reflecting mirror and a light source. The casting has a diameter of 6 inches and a depth of 4 inches. What is the equation of the parabola used to shape the mirror? So I'm just going to look at this first question first. What is the equation of the parabola? So we're going to pretend here, since it opens up, that this is our y-axis and then this is our x-axis. So we're going to call the bottom here the x-axis. I should have drawn it a little better. So if the bottom right here in the where the y-axis crosses, that's going to be our vertex. So the vertex is going to be the point 0, 0 for our hk. And we can see that it opens upwards from that point. So it opens up, and the vertex is at 0, 0. So the standard form of that equation is going to be y equals 1 over 4p x squared. So again, we need to find out what p is, because we don't know that yet. Since the total diameter here is 6 inches, that means half from here to here is 3 inches. And since the vertex is at 0, 0, we're going to go to the right 3 units and up 4 units to get to this point. So on a graph, that point would be 3, 4. And just like the last problem, that's our xy. So then we can solve for p here by plugging in our xy into the equation. So then we have 4 equals 1 over 4p times 3 squared. So then we can simplify 1 over 4p times 9. I'm going to divide both sides by 9 to keep it in the 1 over 4p form. So we have 4/9 equals 1 over 4p. We're going to want to cross multiply to solve for p. So we have like this. So then we have 4 times 4p equals 9, because it'd be 1 times 9. So 16p equals 9. So then p divided by 16, p equals 9/16. Then we can plug p back into the standard form of the equation, and we can write that standard form. So we have y equals 1 over 4 times p, which was 9/16 x squared. So then we can simplify. So 4 over 16 reduces to 1 over 4. So y equals, it'd be 1 over 9/4 x squared. So we're going to want to take the reciprocal so that we get 1 over, or excuse me, y equals 4/9 x squared. Because when, I'll show you off to the side here, when we do that, we get then taking the reciprocal of 1 times 4/9, which simplifies to just 4/9 here. So that's how we get the standard form. So that's the first question it asks. Now it says, at what point should the light source be placed relative to the mirror's vertex? And the light source is going to be the focus point, because that way it's equidistant. So this light source is the focus point. And the focus point, we've already solved for P to be 9/16. So that point is 9/16 units up from the vertex. And the vertex was 0, 0. So for an ordered pair, our focus point is going to be 0, 9/16. Because we go up 9/16 from 0, 0. So 0, 9/16. So for the second question, at what point? This is the point, at 0, 9/16, or 9/16 units up from the vertex, which actually it gives us units as inches, so it'd be 9/16 inches away. All right, thanks for listening. That'll be all for Unit 7. If you have any questions, let me know.